I'm going to share screen. Which screen did y'all get?
One is just class demo.
Okay, you can see. All right. On the beginning of the course page, we've got a link to the Java Online documentation. I'm going to click on that. This is something you eventually need to become very familiar with if you want to be good with Java. Because Java has so many libraries built into it, there's probably something there for everything that you could want to do. But the only way you know how to use that stuff is if you know how to use the documentation. So when I click on that, there's a lot of great stuff here, but we're looking under reference, that first link, the Java SE API documentation. Okay, this is Java 8, which is pretty much the mainstream right now. Java 9, I believe, was just released, and they're supposed to release 10 pretty quick. Which I don't know why everyone hates number 9, but that's what I read somewhere. But this is all still pretty good. Most of the stuff coming out in the newer versions of Java is above and beyond what we cover in this class anyways. I'm just saying it's important to recognize which version you're working with. All the classes are grouped into packages. So that's what you'll see over here on the top left, are the different packages. If you want to narrow, if you're searching for something, you want to narrow it down to a certain package, you could look there. But all of the classes that come with Java by default are right here. And there's a ton of them. But we're looking for the scanner, so we'll go down to the S's. Scanner, there it is. If I click on that, it's going to show me a lot of information about this class. And the way this API is laid out, it will show you what this class is derived from. Java is very object-oriented, and everything is an object. Okay, everything in Java, from primitives to error messages, just everything in it is an object. And it is all derived from either object or something else that was derived from object. Okay, so object is the base class of Java. Scanner is derived directly from object, and it comes from the util package. So when we want to use the scanner, we will have to import java.util. And I'll show you how to do that in just a minute. There's a little bit of example code here. This may or may not exist in all classes. A lot of classes don't have any example code, but sometimes they do, so it's good to look at that. If we scroll down a little bit more, we'll list all the constructors for the scanner. So you can scan a file, you can scan an input stream, a path, a readable. These are all objects in bold there. And these are all the methods associated with the scanner object or the scanner class. A method is a function that resides inside of a class. So in C++ we call these member functions, but I think a better term is method, and in fact everything in Java, all of the functions in Java are called methods because everything in Java is done in a class. So these are the methods for the scanner class. The ones with that we want to look at right now are next. Next is overridden a few times, but it will pull in a string. And so when you want to read in a string as input, you will do scanner.next. That's the method you'll want to use. If you're looking for an integer input, we've got next int. If you're looking for float, double, etc. Next line will also pull in a string. So whether you use next or next line, it normally doesn't matter. Alright, I realize this can be a little overwhelming at first, but you do want to get familiar with this. Don't be afraid to look here. This is where, like, this is your guideline on how to use all the stuff in Java. There's no way to memorize it all, but if you can learn how to use the API, you can do anything. Alright, there's some other stuff in here, but that's the basics of the API and what I want you to become familiar with before this semester is over. Alright, I'm going to move that over here. We're going to go back to our demo program and we'll look at getting input. So up above my class here, I'm going to type import java.util.scanner. And then to create a scanner, we'll drop down here into main. I'm going to scrap. I'm going to scrap all of this code from last time. And I'll create a scanner. Just like that. Alright, for the argument to the constructor, like I said, you could be reading, you could be scanning a file or any number of things. We want to scan input from the user. So to do that, you will type system.out. Sorry, system.in. We're looking for input. System.in. Okay, and you can call your scanner whatever you want to. It's somewhat conventional to call it name it based on the class. Just use the lowercase letter. Right here I've got a lowercase s. But you can, if you want to, you can just call it s, or you can call it scan or whatever you want to. But this is the class name, the variable name. New creates the object. This invokes the constructor, and we tell it we're looking for input from the user, from the keyboard, or the system. Alright, so let's try this out. We'll create an integer called num, and we'll create a string called str, and we'll prompt the user. System.out.print. Remember, if you do print, it will leave the cursor on that line. If you do print line, it drops the line. So if I'm prompting the user, I'm not going to use print line, I'm just going to use print. That's something like enter a number. And then to get that input, scanner.next int. That retrieves it, but we want to store it somewhere. So we want to store that in num. We'll say num equals scanner.nextInt. And then we can prompt for a name. And we can store the name in str. You can try next or next line. I think both work. I've probably got some errors in here, so let's go ahead and try this out. I need to save, and then I need to open the command prompt, CMD, and navigate to my Java directory. Mine's on the C drive. Under Java stuff. Any questions so far? Is everyone keeping up? All right. I'm going to take that as a yes. Remember, when we're coding, we're working with the .java file, so I'm going to invoke the compiler, javac demo.java. It's going to attempt to compile that code I just wrote. I didn't get an error, so this may work. If you did get an error at this point, you need to go back, correct your error in your text file, save it, and try to compile it again.
What happens if your folder isn't there anymore?
There's deep freeze.
So where you got rid of it?
Oh yeah, definitely.
I'd say in Java C is not recognized.
You probably have to reset your path environment variables.
Do that whole thing again?
Yep.
I guess I'll do that on the break.
Why?
I don't want to fix it.
You're going to get behind. If you need to reset the path variables, go ahead and do that.
What was the first thing I did?
Environment
Oh, yeah.
variables. You're going to click on it, environment variables. You don't click on this path up here. You click on the path down here in the second window.
And when you hit that, you hit new or you just double click? Oh, yeah,
Double click path. Then you can hit new. And you want to add this Java/JDK, whatever it is,
Oh, we're supposed to save that.
/bin /.
Where did we find that thing at? Oh.
Program files,
Okay.
C drive program files. I mean, you can see it, you might can see it on my screen. I know it's going to be really small, but the location is right there.
Mr. Gordon?
Yes, ma'am.
What's the line that we have to write before the Java?
The what?
I feel like there's another line that we're supposed to do before the Java to run our thing.
It's Java C. Don't say it weird.
Phonics.
I've never heard anybody say that. You're running Java C, and you type in your file name, right?
Yeah, if we reset our environment variables, we should probably reopen our environment.
Yes.
Okay.
Yes. If you have to reset your environment variables, you need to close the command prompt and reopen it. Is anybody hung up? Are we making progress?
Hung up just a little bit.
Okay, what are you hung up on?
editing the environmental and variable. That's where I'm going.
Did you make it this far?
I am there.
You want to click on here and click New.
Oh, okay. Oh, that's easy. Okay. Oh my God, that's the
So to run it now, I'm going to type Java, that's the virtual machine, and then I type demo, enter a number, I type a number. It says enter a name, but immediately skips over it. And that may be because it is retaining the return character from the previous scanner entry. So I'm going to minimize this for now. And I'm going to look back over here and see if there's anything we can do to clear that out. There's a reset. Let's see if that works. It says it resets the scanner. So let's try that. Save it, compile it, run it. I didn't do anything. I'm looking for like a clear method or something like that, but I'm not. There's a remove, there's a close. I don't know. Let's try all of them. Apparently remove takes an argument and it did not like that. Alright, we'll try something else. Let's try close. That didn't work either. Something else we could do is just reset the scanner, not using the reset function, but we could create a new scanner. And I don't remember having this problem before. I would be better equipped to handle it, but We can just recreate a new one. Now in C++, this would be a problem. Does anyone know why? No? Kaylee?
We need to delete the other one.
Yeah, you would need to delete the other one or you got a memory leak. Java has a garbage collector that's going to take care of it for us. We don't have to worry about memory leaks in Java. You can create a memory leak, but it's really hard. Yes?
I looked it up and it says not to use X line for gathering string variables from text because that won't work.
Just use next.
Don't use X line. That's what I have.
The next works.
Okay. Good to know. I don't know why I didn't try that.
I looked it up on Google when I was doing the first thing I came across.
It's the morning.
I'm gonna try what I did, and then we can also try next. Yeah, that works just fine. But let's also do next, because it's a little cleaner. Cool. Was everyone successful? Any questions? All right. There's the scanner. Just remember when you're getting input, you do have to put the next whatever you're looking for. So if you needed a float, you would have to type next float. Otherwise you'll get an error.
So my enter name line isn't displayed.
Look at it.
So when I run, what's basically on it doesn't display the enter name.
Did you see? You've got two open there. Okay. Did you see? That's why. Yeah, get rid of that one. It's almost gone.
I didn't know you
Save that.
like sitting there pouring. I'm like, it's not all gone. I feel it in there. Either that or this is just heavy.
All right, I'm going to roll through chapter 2 here. We've already covered some of this, but the things that we haven't covered, I'm going to touch on again. How many primitive data types in Java? 8. Everyone knows what those are, right? Yes. Not string. Here's something, if you wanted to create a float, you can do that and that would work. But sometimes you'll see F on the end of it. It's because if you don't put the F there, it assumes it's a double. If you do put the F there, it doesn't even, it assumes it's immediately a float. What happens here? What do you expect to see for output in this code? There shouldn't be any output, but we do get an error. If you look at that, it says integer number too large. Can a long store 3 billion as a value? Can an integer store 3 billion as a value? You guys should know this. What's the largest number you can store in an integer? Yeah, 2 billion and some change. That's 32 bits. 2 to the 32nd power. So if we say 2, oh, this calculator's no good. We say 2 raised to the 32nd power, we'll get 4 billion and some change. Now, half of those bits are reserved for, or half of those values are reserved for negatives. So if you divide by 2, that's how many you get. That's the biggest number you can store in an integer. I think that's -1. Well, Java doesn't support unsigned. So can I put 3 billion in an integer?
No.
No. What is a long? If an integer is 32 bits, long is going to be 64 bits. It's going to be on the test. 2 raised to the 64th power, and then we'll divide by 2 to give it the negatives. But we should be able to store whatever that is, which is way bigger than 3 billion.
1 trillion.
All right. The problem here is, if you just type a literal number, and we will call this a literal. It covers literals in chapter 2. If you just type a literal number there, it will take it to be an integer. So to specify that this is not an integer and that it will in fact fit, put an L on the end of it. That's a long. So you've got an F tag that makes it a float, and you have an L tag that makes it a long. If you save this now, it should run just fine. Yeah. We talked about Boolean types. What can the values be? True or false only. The part about literals is on page 39. can also specify that something be hex. We talked about escape sequences and strings. There's a list of escape sequences on page 40. You should at least know 3 of those. That'll be on the test. You can also have a string literal, right? What is a string literal? Well, it could be a name. The literal is the value being assigned to the string. So whatever appears in the quotes. If I say string str equals something, the something is the literal, right? This is the literal. Whatever appears between the quotes. That's a string literal. Everyone should be familiar with scope. If I create a variable within a pair of brackets, the scope of that variable is limited to those brackets. Right, so if I create some variable float num here inside class demo, if I had another class or another function outside of those brackets, it would not be able to see that variable there. I hope everyone should already know this.
Are we capable of making global variables and stuff?
You can, but they're more like class-wide variables. They're not truly global because everything is in a class, but you can have nested inner classes and then just have the variables declared in your outer class, and then it's as if they were global, at least within your project. Arithmetic operators, we talked about those. Plus, minus, multiply, divide, modulus, increment, decrement. What do you expect to see for output here? 21? 20? Some people said 21, some people said 20. I got 20. Why is it 20? Post increment, which means it is 21 on the next line, but as far as this statement goes, it's still 20. We do the pre-increment, we should get 21 because it will increment it first and then it executes this statement. Yeah, 21. So understand how prefix and postfix works. We talked about the relational operators. Hopefully everybody knows those. There's 6 of those. Equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. And then we've got our logical operators. Well, since I'm recording, I won't write on the board. I will just type it out here. This is your standard AND. The ampersand sign, This is or, and this is not. And you also have a XOR. Or exclusive OR. And then we have some short circuit operators. This is a short circuit and short circuit OR. All right, what you see on the left are the operators. If I ask you for the operators and you write the word and, you did it wrong. So that is not an operator. The symbol is the operator. This is what it does. All right, if I have, I am going to write on the board. If I have true and true, what's the result?
It depends on
The whole
It's true. This is true. If I have false and true, false, right? What if we change these to or? They're both true? Right, because with or, as long as one of them is true, the statement is true. Now, what if I put more conditions here? And these all both evaluate false. Still true because as long as one of them is true, the statement is true. This is where the short circuit and an or come into play. Right? If I do two of these, which you would do in C++ anyways, what it will do is it starts evaluating this statement. And since we're ORing these things, if it finds any of them that are true, it doesn't even look at the rest. So this is a little bit quicker. When you're counting the nanoseconds, this will be a little bit quicker. Because it knows if this is an OR statement and it's got a true value, it doesn't matter what the rest of that is, this statement is true. Same thing with AND. We have a short circuit AND. What's it looking for? False, because if it finds anything false, this statement is false. And it doesn't even need to look at the rest of them. So this will be on the test. You'll need to know the difference between a regular AND, short circuit AND, regular OR, and a short circuit OR. You also need to know that the short circuit version is actually the one that has two symbols, which is kind of backwards because you want to think the short one would be the small one. It's actually the one that carries two symbols. That's on page 48. What is that? This is OR. We talked about it.
top one is false, bottom one is true.
Top one is false. The exclusive OR, you can have one or the other, but you cannot have both. So true XOR true is false. False XOR true is true. Does that make sense? And then false XOR false would also definitely be false. Huh? Yeah. With XOR, one of them can be true, but not both. You can have this or that, but you cannot have both, like a regular OR. Does There's no short circuit XOR.
So for the XOR, what kind of situation would you use that instead of the short circuit or the OR operator?
I don't know a good example. I think you would know when you get there if you're coding it and you're looking at two conditions and you want it to be one or the other, but not both and not neither. If you decide whatever you're coding you need that, that's where you need a XOR. It's probably the least used, but that is what it does. I don't have a good example.
Okay.
I know it is nice to have, because when you do need it, it's nice to have one. There's a little true false grid on page 49 that shows how each of those operators work. The not operator just flips the value, right?
Yep.
So if it's true and you have a not in front of it, then it's actually false, and vice versa. If you have a not with a false, it's actually true. That's pretty much it for chapter 2. Let's take 5 and we'll start on chapter 3. So switch is if you don't want to write a series of if-else statements. You want to check for a specific value and then address that value with a certain code. Let's prompt the user. And we'll set our switch up based on that number. And the syntax is just like C++. Again, I like to label these guys. So I know what my braces are doing. Now our switch needs to look for a value. We stored that in num, so I'll put num in the parentheses here. And then within the switch, we have cases for each value that we want to handle. So case 1. I'm not going to do anything really fancy here. I'm just going to say entered case 1. And then every case is followed by a break. Otherwise, if you don't put the break there, it will run the next case and the next case as well. It just keeps on going. So case 2. And you can skip numbers if you want to. Let's do case 50. Oh, I forgot the break. Now you can put just about any code you want inside here. It doesn't have to be print line statements. You could do if statements, loops, other switches, you know, nested switches. You can do math, get more input and things like that. You can nest these switch statements however deep you want to. They don't have to be in order, and they can skip values. In C++, these have to be integers. Yes?
Are you required to put a default?
What?
Are you required to put a default?
Not required, but it's always a good idea.
Okay.
So you can have default case.
Put a break default.
What?
And a break default at the end of the switch statement.
Not necessarily. I don't think you do.
So it's the same like in C++.
Yeah. In C++, these have to be integers or enums.
Okay.
In Java, you can use strings.
Oh, that's cool.
So yeah, that can be cool. You can have your switch checking out a string instead of an integer, and then you can base all your cases on strings. So we'll look at that in just a minute, but for right now, let's make sure we have this working. I'm going to wrap the switch in a loop. So I can test it multiple times. I'm going to put the loop, I'm going to start the loop up above. Up above my input. Which means I need a Boolean for running.
We have to, yeah.
And then I'm going to have a case that kills it. If I type in 100, it's going to kill the program. So let's try this out. Go ahead and save it. Compile it.
You don't have your scanner.
Scanner is AFK. That works. And then let's run the program. Java demo. Enter a number. I know I've got cases for 1, 2, 50, and 100 will kill it, and then I have default to handle any other number. So let's try 1. Enter case 1, my loop is working. 2, enter case 2, that works. 50. 3. 3 is going to hit the default. Anything that's not accounted for will hit the default.
What happens when it's a string?
It'll probably crash. And it should be able to enter 100 and get out of that loop. Yeah, that ends the program. I like to have a space right here. I don't know why I didn't do that. All right, any questions? Was everyone successful?
Yes.
Everyone. All right, that's a first. Now I'll give everybody a minute, and then if you have questions, let me know.
Yeah, that's pretty cool.
Okay, let's switch over to strings. Let's try strings. We'll change our integer to a string. Instead of next int, we'll just do next. And then our switch will run on str instead of num. That part wasn't important, but it's a little more intuitive. And then our cases will need to be in quotes. So we could put, instead of enter a number here, we'll change this enter a name. All right, we'll have a case for Bob. You can put some message here, whatever you want to put. We can have a case for Fred. And we can have a case for Mary. For default, we can say incorrect name. And for quit, we kill the program. Yep.
Would it be possible then just to write a bunch of cases and leave them blank without putting a break on them? If you wanted to just take one response to the same answer. So like case spread within all big lowercase and then case the first one.
Normally what you'll do is you'll write these all lowercase or all caps. If you wanted to do that, and then convert your string to whatever. There's conversion functions that would make the entire string uppercase or make it all lowercase, and then that would handle, you know, if you didn't want to be case sensitive.
Alright, but if, say for example, you wanted more than one name to have the same response, could you do something like that? I put case Bob, then immediately after case spread, and then if it goes to Bob, it should drop into case spread as well.
It would run both cases.
Yeah.
So it wouldn't run one or the other, it would run both for Fred or Bob, and then it would only run Fred's for Fred.
See that? So, well, if you leave Bob's blank, so like, say you want Bob and Fred to have the same response.
So if you do this,
Yeah. If you put Bob or Fred, it would run essentially the same thing.
yeah, I think so.
Okay.
Maybe.
Cool concept.
I don't know why it wouldn't.
That's a cool concept. Alright.
One thing you can't do with the switch though is you can't specify a range. So you could not say, you know, you can't say Bob or Fred. That would not work. This is wrong. If you're doing numbers, you cannot say, you know, between 3 and, I don't know, between 3 and 9. Or let's say greater than 3 and less than 9. You can't do that. You can't specify a range like you can with an if statement. It has to be specific values. All right, let's save this, compile it, see if it works. Try Bob. Try Fred. Try Mary. Try Joe. Incorrect name. Try quit. That works just fine. Any questions about the switch? All right, let's scrap the switch. We've got a loop here. Wait a minute, maybe I'll leave the switch in there. Never mind, Control Z doesn't work in Notepad. Oh, another thing we need to look at is comparing strings. So let's say we don't have the switch, we want to use if statements. So if str, you're going to want to say if str equals quit. Alright, this is wrong. And it will probably compile. What this When you compare strings this way, it's actually comparing the references. We'll compare this reference to this literal. It's not actually comparing the characters like you would expect in most languages. And so, to compare two strings, you will use dot equals. Now if I had a string, let's just say I had a string str2 equals Fred. And then I create another string and set it to 2, I could use the equal symbol. Because that's what it checks. It's saying, is this the exact same thing as that? Not are they the same value, are they pointing at the exact same place in memory? That's where you can use equals to compare two strings, which is very rare, so just don't do it. If you're wanting to compare the value of two strings, you're going to use the dot equals method. Alright, with that, let's do our if statement here. It equals quit. We can type break. What will that do? Would this kill the program? Well, break actually only works with loops and switches. It doesn't have any, it doesn't work with the if. It doesn't really matter. There's nothing to break out of when you have an if. Let's try it. It does kill the program. How does the break statement work? Someone tell me what a break statement does. Get you out of the loop. How many loops? Just one. So if I have another loop up here, for whatever reason, now does it kill the program?
No.
No, I'm trapped.
You would need a way to exit the program.
Right. Yeah, it doesn't work. Break will only get you out of one loop or one switch. So if you want to break out of multiple loops, there is a weird little thing you can do. You can create something called a label. A label is kind of like a case statement. It's just some word with a colon behind it. And then you create another set of braces here. Sorry, quit braces. And then when I call break, instead of just calling break, I tell it where I want to break out to. So you can break out of multiple loops if you set up labels. If I've done this correctly, I don't know. I like seldom use this in practice, but it is a thing, and I thought it was kind of cool. So I would close my command prompt. That works just fine. Any questions about breaking out to a label? Make sure your label's on the outside of wherever you want to break out to. But then you can break to that label, and you can name this just about anything you want to as long as it's not a keyword. And then you can call break to that specific point. And you can nest these things inside of each other. The code gets a little bit sloppy if you do it that way, but it is a thing and it does work. So you could have several stacks, and he shows that towards the end of chapter 3. He sets up like 3 different labels, and he shows you how you can break out to different ones, just depending on what you want to do. So there's breaking out to a label. Any questions? I think that's it for chapter 3. Oh, there's a continue statement in a loop. Who knows what continue does? No. Wouldn't it do that anyways? Doesn't a loop continue looping
It does.
by itself? So it makes no sense that a continue statement would do exactly what it's going to do anyways. What? No, that's break. Goes to the next iteration of the loop. Basically restarts the loop, which is without finishing the current iteration. It skips everything else in the code and just restarts the loop, which is confusing. That's why I like to put it on the test. Yeah, it's the exact same as C++. All right, that's it for chapter 3. Let's look at the lab. You're going to write a program that calculates the total amount of money spent when financing something. You're going to prompt the user for the initial cost of the product, the APR, that's an annual interest rate, the amount of time that you're going to finance it in months, and then you're going to calculate the interest over that time, and you're going to display the results to the user. You're going to format your values to 2 decimal places. Okay, there's several ways of doing that in Java. There's a class called formatter. So if I want to look up formatter in the API, go all the way up to the F's. Formatter. 2 formatters. Lots of documentation on this guy. This formatter is abstract though. This one is not. What does abstract mean?
Vague.
What?
Vague. Too vague.
Too vague?
Abstract? Yeah, abstract.
In reference to a class, if I have an abstract class, what does that mean?
It's just a basis.
Class that
Cannot be instantiated. You cannot say formatter equals new formatter if you're talking about this formatter or any other abstract class. You cannot create an instance of an abstract class. What you can do is derive other classes from it, and it lists the ones that are derived from this one.
that makes sense.
So the one you want is the one that is not abstract. You want to be looking at this guy right here, the first one that's listed, and try to find something that will allow you to format a number to 2 decimal places. You're going to be working with floating point numbers, or if it's beyond the size of a float, there's a big decimal class that handles really big floating point numbers that are bigger than a double. So double is going to be good enough though for this.
Click on the other format. I don't know if that was
What? This one? What about it? Yeah, it says it's abstract.
Oh, okay, I see.
Everything needs to look clean and professional. So if you need to format your output so that it looks like a professional program. You're going to turn in your program as the text file, and then you're going to add some comments to the bottom of it, and that's going to show me that you compiled it and that you ran it correctly and the output for your program. Just some demonstration of your program. That's what you're going to turn in. Any questions? All right.